So Newton law of motion 2.2. The first law saying the net force as acting on object is zero, that object maintain in its state rest or constant velocity. Okay, what does it mean? If an object is moving with constant velocity, v constant, means the acceleration is zero, right? Means the total force is ma, the total force is zero. If you see, if I say, if something is moving and I say total force on an object is zero, so investigate that. Am I saying it true or not? So you need to measure the velocity. Is the velocity changing or not? If the velocity is constant, you say yes, total force on an object gonna be zero, is zero. So that's true. But if the velocity is changing, you have acceleration, and no, net force not gonna be zero. Or if something is resting on table, the net force is going to be zero again. The acceleration is zero. The net force is zero. Any question? So this is the first law of the Newton. The question, a 12-passenger jet aircraft mass is given as traveling at a constant velocity of the 850 while maintaining a constant altitude. What is the net force acting on it? So it's moving constant velocity. What does it mean? Net force is?
Zero.
Zero, right. You exert a force 45 out on a backpack, causing to move upward with a constant velocity. What is the force of gravity on backpack? Since there is two force, force of apply that you push your shoulder, push the backpack up, and the gravity. Since it's moving in a constant velocity, I'm sorry, is not moving, right? In y direction is not moving. But you're moving forward, that's fine, but in y direction, there is the net force in y direction going to be zero. Force of apply will be the same as force of gravity. They need to cancel. Okay, so gravity of the backpack going to be the same as force of apply, but in opposite direction. Any question?
No.
As another question, the traction system. So basically you have forces. This is 18 Newton down. This 18 Newton down, we're gonna give you the same 18 here, right? Because this is tension. This is F of T.
Yep.
Downward is F of T, F of G. F of G is 18 Newton. Therefore, it's not moving, it's just a stationary. Therefore, these two forces, F of T, need to be 18. Therefore, since it's the same rope, this tension is going to be 18. So you have that. You have another force of tension, but you don't know the X and Y component of that. So you find X and Y component of this force, you find X and Y component of this force. They need to cancel, right? The X and Y component need to cancel. Also, there's going to be a force here. This is another force. Actually, they put it in an angle. No worries. And they put this one to be F of T, you know, because this is not broken. True, all of that is the, so this F of T here is going to be 18. I'm going to put this one as the angle. There is a point of contact here because there is the leg put some pressure on this point. And this could be with an angle. Basically, you have two vectors, one of them is unknown. So you find all of the X components. You find all of the Y components, and then all of the X component add together should be zero. All of the Y component add together should be zero. Because the net force is zero here. F of T, this is 2X component for the rope, and this is for the leg. And make sure one of them is positive, one of them is negative. So they add up to zero. For the Y component, they do the same thing, add them up equal to zero. So then you got X and Y component of your unknown force. You put them together using the Pythagorean theorem. You find the angle using tan inverse. Okay, so for the question you do, so this is page 81, question number 6 and 7.
Okay, got it.
Okay, Newton's second law of motion. It said if the external net force on an object is not zero, the object accelerates in direction of net force. The acceleration is directly proportional to net force and inversely proportional to the object mass. So basically is F is equal to ma, right? Acceleration is the vector. So acceleration is force divided by m. The acceleration is proportional to the force directly, but is inversely proportional to the mass of the object. Means more massive is the object, the acceleration is smaller. Anyway, this is your second law of motion, force is equal to ma. The question, the mass of hot air balloon including passengers is 910 multiplied by 10 power 2 kilogram. The force of gravity is given. The density of air inside the balloon is adjusted by adjusting the heat output of the hammer. Okay. So the force upward is 9.910 power 3 Newton. Determine the vertical acceleration of the balloon. So you just need to do the FBD diagram, all forces. You have a force of gravity, if you have a force that push your balloon up, right? So since there is an acceleration, net force not gonna be zero anymore. So force is equal, total force is equal to ma, right? Force of apply is positive minus force of gravity is equal to ma. So you're asking to find the acceleration. Force of apply is given to you, right? The force of gravity is given to you. The mass of the object is given to you. So all of this is given, this, and this. You just need to find acceleration, got it? Good. So as you see, they've done it here, force of apply minus 1 divided by m, so you get it. So the question you do, question number 10, 11, and 13. So that was page 83. Weight and Earth gravitational field. You know that on the surface of the Earth, we have a gravitational acceleration. So this is Earth. Gravitational acceleration is 9.8, is g. Any object will get that acceleration, doesn't matter how massive it is, because the field. As you go higher, of course the g gonna be different, right? The g will have another value when you go away from the Earth, because the more distance you are from the Earth, the field will be weaker, right? So the force will be weaker. The gravitational acceleration going to be smaller. But here is on the surface of the Earth. We take it to be 9.8. Most of these questions are on the surface of the Earth. So basically, here the equation that you have, f of g is equal to m multiplied by g. G is 9.8. Okay. Now determine the following. This is question 16. You just do question 1684. Third Newton law. Third Newton law is saying for any action, every action, there is a reaction. For example, if I push the chair down, the chair pushed me up, because my action is just pushing something down. So the chair reacting in opposite direction. So here is an example that this help you. When force on the road, when you have this wheel is turning, the wheel is push the earth back, and earth push the wheel in front because of the action and reaction. Same thing when you're walking. you push the earth back and earth push you forward when you walk on it. Also, when you're in a boat and you push the water back and the water push the boat in front. Any question?
I'm not.
Okay, so a softball player sliding into third base experience the force of friction. Describe the action reaction pair of forces situation. Okay, so so it's kind of force of ground. The player will push the ground back and the ground push the player forward. Same thing. So you don't have to do anything here. And that's it. This is 2.2.